So let's talk about the Coulomb and the Coulomb's law. Now the Coulomb is the amount of charge flowing through a cross-sectional area of a wire in 1 second when the current in the wire is 1 ampere. The fundamental unit of electric charge is related to Coulomb by E is equal to 1.60 times 10 to the power of minus 19 coulombs. So this shows the relationship between the fundamental unit of electric charge and the Coulomb. Alright, any charge Q occurring in nature can be written as Q equals plus or minus NE, where N is an integer and it can be positive for protons and negative for electrons. Alright, so simply get down to some exercises. So we have here a small copper plate has a mass of 3 grams. The atomic number of copper is Z equals 29 and the atomic mass is 63.5 gram per mole. What is the total charge of all electrons in the copper plate? Now, first of all, we have to consider the N. So we'll have our solution. So now to find N, we are going to multiply the mass by the Avogadro's number or constant, which is 6.02 times 10 raised to the power of 23. Then we'll divide this by the atomic mass of copper, which is 63.5. Now when we do this, we can now get the number of atoms. So this will give us 2.84 times 10 to the power of 22 atoms. Alright, now let's recall that E, which is the fundamental unit of electric charge, is 1.60 times 10 to the power of minus 19. So now, employing our equation, Q is plus or minus NE, right? But since each atom contains 29 electrons from the question, the total charge of all the electrons will now be given by Q equals 29 electrons times N, which is 2.84 times 10 to the power of 22, then times 1.60 times 10 to the power of minus 19. So when we do this, this will give us 1.32 times 10 to the power of 5. Now notice that I added a minus sign here. Now the reason for this minus sign is because the question says what is the total charge of all electrons in the copper plate? Now recall that from our equation, we have Q to be plus or minus Ne. And for protons, we use plus. For electrons, we use minus. Now, since we are calculating the total charge of all electrons in the copper plate, now this equation holds for the minus here. So we have minus 29 times 2.84 times 10 to the power of 22 times 1.60 times 10 to the power of minus 19, then to give us this. Alright. So let us consider the Coulomb's law. Now the Coulomb's law states that the force between 2 point charges is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Hence, we have that F, which is the force, varies as Q1, which is the charge at point 1, and Q2 times Q2, which is the charge at point 2, over x squared, which is the square of the distance between them. So this represents the Coulomb's law. Now, if we further simplify this, we know that F becomes, we have F is equal to KQ1 Q2 over x squared. Now, where the K, which is the constant, is a popular constant, I believe you know of, which is 1 over 4 pi epsilon naught. And this constant has a value of 9.0 times 10 to the power of 9, whereas this epsilon naught has a value of 8.85 times 10 to the power of minus 12. So you can simply always use this and then simply plug it in direct to your calculations, or you can simply make 1 over 4 pi epsilon naught by using the value of the normal value of your pi and the value of your epsilon naught to be 8.85 times 10 to the power of minus 12. Alright, so having this way, we can simply write that F is equal to Q1 Q2 over 4 pi epsilon naught x squared. I will know the reason. We are multiplying. We actually did this 1 over 4 pi epsilon naught multiplied by Q1 Q2 over x squared. Now when we multiply this, we multiply the numerators out, then we multiply the denominators out, and simply realize this. Alright, so let's go ahead and delete this. So our last expression, which is varies Q1 Q2 over x squared, is so much similar to the Newton's law of gravitation, which states that the force of attraction between two masses m1 and m2 is proportional to the product of the masses and inversely proportional to the square of the distance between them. Perhaps we have that F varies as m1 m2 over r squared, where r is the distance between them. Now notice that the distance between the 2 point charges here is denoted as s squared, and the distance between the masses here is denoted as r squared. Perhaps we can bring this to a common variable, say reinterpret this to be F varies as m1 m2 over x squared. Now this is to enable us to make some future calculations that we'll be making in this process. Now we are trying to compare these two. Alright, so now I'll simply put up this equation. I'll simply put up this as an equation. I'll have F equals gm1 m2 over r squared, where g is the universal gravitational constant. So with this, let's also recall that we can actually write this to be F equals g m1 m2 over x squared. So I'll go ahead and wipe this off. So let's take an exercise. So we have here, by assuming a hydrogen atom consists an electron of charge negative E and a proton of charge positive E. Calculate the ratio of electric force between the electron and proton to the gravitational force between them. Now let's take mass of electron to be 9.1 times 10 to the power of minus 31 kg, and mass of proton to be 1.67 times 10 to the power of minus 27 kg, and then the universal gravitational constant, which is 6.67 times 10 to the power of minus 11 Newton meter square per kilogram squared. Alright, so we'll go ahead and then solve this question together. So first of all, I'll have to wipe this off. So let's apply the Coulomb's law first. Let's say this is 1 over 4 pi epsilon naught times Q1 Q2 over x squared. And then let's also recall the gravitational force. So Newton's law, let's say F is equal to G m1 m2 over, in this case let's use s squared. Okay, now having this, let's say we have Q1 Q2, we'll multiply these out. We have Q1 Q2, and then we'll multiply these out. So Q1 Q2 over 4 pi epsilon naught x squared. So this will be divided by, since we want to find the ratio, this will be divided by G m1 m2 over x squared. So the next thing is to change the sign of division to multiplication. So when we change this sign to multiplication, we'll now have an inverse of this. So the equation will directly change to Q1 Q2 over 4 pi E naught x squared times x, sorry, x squared over this. So I'll have x squared over g m1 m2. Now notice we have x squared here and we have x squared here, so we can cancel off x squared. So this equation will in turn be q1 q2 over 4 pi epsilon naught g m1 m2. And notice that q1 q2 can also be retaken to be e squared since the charge in the proton is same as the charge in the electron. So we'll have e squared over 4 pi epsilon naught and g m1 m2. Alright, so we'll take this off and then we'll wipe the rest. Alright, so from here our e squared will be 1.60 times 10 to the power of minus 19 . So this will be squared now over 4 I epsilon naught over 4 pi. Remember that our epsilon naught is 8.85 times 10 to the power of minus 12. Then times our g, that's universal gravitational constant, which is 6.67 times 10 to the power of minus 11. Then times m1, which is mass of electron, and the mass of electron from here is 9.1 times 10 to the power of minus 31. And then we'll have m2, which is the mass of proton, that's mp. Then I'll have 1.67 times 10 to the power of minus 27. Alright, so now we have all these. So you simply plug it in your calculator and then you realize the final 2.27 times 10 to the power of 89. So this becomes the ratio. So we notice that there is more of an electric force of attraction than that of gravitational force between the proton and the electron. So we'll go ahead and try further examples on this. Alright, so let's look at this question. It says, what is the magnitude of electrostatic force of attraction between an alpha particle and an electron 10 to the power of minus 13 meters? Alright, now first of all, we have to notice the charge in the alpha particle. So an alpha particle will have 2e. Alright, so what's the reason for the 2e in the alpha particle? Now the reason is an alpha particle has a helium nucleus which is consisting of two protons and two neutrons. So an alpha particle will have two protons and two neutrons. So for that, the charge is positive 2. Whereas an electron will have just 1e. Alright, so now having said that, we are going to still make use of our F to be, that's the electrostatic force, to be Q1 times Q2 over 4 pi epsilon naught x to the power of 2. Alright, if we do this, we can also see this to be e squared over, now at this point we'll make use of 2e squared over 4 pi epsilon naught x squared. Now the reason we have 2e squared is q1, which is 2e, times q2, which is e, will now give us 2e squared. Alright, so if we have 2e squared this way, the value now becomes, alright, 2 times 1.6 times 10 to the power of minus 19 over 4 pi times 8.85 times 10 to the power of minus 12, then times s squared, which is the distance between them, and that is 10 to the power of minus 13. So let's recall that this is squared and this is also squared. Okay, now let's punch this on our calculator and see what we have as the results. So we'll check our calculator. We'll realize this 4.6 times 10 to the power of minus 2 newtons. So this becomes the force, the electrostatic force between them. Alright guys, so that will be all for today. Next class. If you've not subscribed to our channel, please try to subscribe. Also like, share, and comment on the videos. to enable us make more videos like this. Thank you.